about my talk is that it can be really short. It can be pretty long. That depends on the questions people ask, if they ask any. I would like to be asked questions during the talk, and I would like a lot of them. Don't be shy. Ask all the questions. There are no silly questions. And please, one of the moderators, could you just interrupt me and ask the questions so that
sure.
there's only one person that reads them. Cool. So hello everybody. I'm Adrin. I live in Berlin. I co-organize also the PyData Berlin meetup, and I work on Scikit-learn most of my time. In this talk, I'm gonna talk about how you could write a Scikit-learn compatible estimator, what that means, and why you would want to do that. I guess I need to increase the size a little bit. Let's say, so what is Scikit-learn? Most of you probably know it's a machine learning library implementing statistical machine learning models. It is not a deep learning framework that is completely out of scope. And for now, we don't necessarily support GPUs. I can get deeper into that, what that exactly means. It's kind of work in progress, but it's not what you get with TensorFlow or PyTorch. If you want to do support vector machines or linear models or a random forest, all of those you do have. Then what are the important parts of the API? You have the main part where usually people start are the estimators. Those are your transformers and predictors. You can have a PCA is a transformer. Select k-best is another transformer. But if you do a support vector machine or if you do a random forest, then that's a predictor. If you do regression or classification, then you have a predictor. You have a bunch of scorers. You have different scoring methods. And you, like, depending on your use case, you use one of them. And then you have a bunch of meta estimators that are usually underappreciated by our users. The most important ones are the pipeline and the grid search. Let's see what it looks like when we use them. Here, let's say I am getting text. I need to process the text and I need to classify. Let's say I'm doing intent classification. I have a bunch of sentences. I want to know, like, this is literally what I did in one of the jobs I had. The users would talk to the device. We would get the text of what the users say. And now we needed to know what to do. Do I need to play music? Do I need to turn on the light? Imagine you're talking to Alexa. That is the task you have. And then you would pre-process that, count vectorizer, TF-IDF transformer, and then at the end you do your classification. And the output of that would be your intent. You put that in a pipeline. And when you do that, that means that you can treat all of them together. You just have one model which accepts the string, the sentence you have, the utterance you have, and it does it. It does what you want it to do. Each of these, in machine learning, you know that we have hyperparameters, and one of the main things that we do is the hyperparameter optimization. We need to find what are the best parameters that we have that suit best for the data we have and for the problem we have at hand. So here in this pipeline, the way I can access my parameters are that I can say, well, my vectorizer has a max DF, it has an n-gram range. My classifier has a maximum number of iterations, the alpha and the penalty. And I put all of that in a grid search. I say, hey, I want a model. My model is the pipeline, and these are my parameters. And then what I do is I call fit on this grid search. So I don't call fit on my estimators. I don't call fit on my pipeline. I call fit on this grid search, and the grid search gives me an estimator interface. It gives me the best model, and I can use it to predict the outputs. The reason we do that is that one of the things that happens when you look at people's codes is they're leaking information from one step to another. For example, assume you want to do like a scaling of the data. You want to do like a kind of a normal scaling, which means that on each column, for example, I would need to estimate the mean and the variance, and then I would rescale my data based on that estimated mean and variance. If I do that on my whole data, I'm cheating because I'm looking at my test data to estimate my variance. That is an information that I'm leaking from my test data to my train data. I need to calculate those parameters that I have on only using my train data. And when I do grid search, if I do like a cross validation, like a, let's say a k-fold cross validation, I need to recalculate those values at every fold. Otherwise, I'm leaking information. If you put your models, if you put your transformers and your like everything together in a pipeline in a grid search, you're avoiding that because this is doing that for you. It's gonna refit everything for you at every step for every fold. So it's pretty important. Now we have all of this. It's really flexible. We have a ton of it in the library. Why would we need a custom estimator? Well, we don't really include all the algorithms out there. That's not feasible. You have literally thousands of papers published in machine learning journals every year, if not every month. We also don't necessarily include things that are very use case specific because it's a general library. So you may have a use case and you may have a very specific thing that you need. It's not included. Or you may do like some extra stuff like, do you want to audit your estimator? Do you want to log somewhere in a database every time that an estimator predicts something on a data? You could write a meta estimator wrapping around your estimator, and then every time that anybody calls the predict, it would just log that in the database. Another thing is if you're a researcher, you usually would like to write your own estimator because you're working on something which is pretty new.
I'm sorry, Adrin, there's a
Yeah,
question.
sure.
Regarding the parameters, can we
Yeah.
have a range of values instead of interpreting the exact values?
Yeah. Yes, I think you can even if you use instead of grid search, you do random. Yeah, if you do random grid search CV, I think you can pass a distribution to the parameter, and you can definitely have a range as well. So one thing I do usually is like in a real scenario, if I have an integer, I would just pass a range. But the range is generating those values for you. Or if there's a distribution over the parameter space, then I just pass that, and then like it samples from it. I think I'm pretty sure the randomized grid search CV does that. Anything else?
No, this is the only question
Okay,
till now.
cool, thanks. So now, what's the example we have here? Imagine we want to do some classification on text, and I want to do that using Spacy. Spacy is one of the so we have a few libraries out there for doing NLP related stuff. You have NLTK, which is really academic. You have Spacy, which is really nice and it is really used in industry, but it's not necessarily Scikit-learn compatible. And it also includes a lot of the pre-trained models that you have out there. So it is state of the art. It's a company here in Berlin. They use the library in their consulting jobs. So it is something used in industry by definition, and they also maintain it and make the same library. Now what I want to do is I want to load a model, a language model. Here I have the code, like maybe I can explain it. You install Spacy as usual when you install any library, but you need to download a model on top of that if you want it, because some of the models are really large. And then I'm using a toy data set, 20 news groups. It's a classification problem. I'm using a linear model, and then I use my train test split just to split the data between to train and test. Now I load the model, the spacey model, and I apply that to my data to get the feature matrix. The feature matrix at the end is going to give me the embedding of the documents. If you know what an embedding is, it's more like an embedding of a word. Think of it as the input is word, the output is an n-dimensional space where similar words are supposed to sit near each other. So when you look at that, usually the standard number of dimension is 300. In this case, because I'm using a small language model, it's 96, I think. And when you look at it, you have adjectives that are similar sitting together. You have the opposites having the kind of similar distance between like different opposites. And you can do math on top of it. As in you can say, let's say I do Putin minus Russia plus Angela Merkel. You would get Germany as the closest point to what you get on that number. So like you get a lot of semantics out of it. Now you can apply that same principle kind of to whole documents or sentences. So this is very simply just giving you the embedding of that whole document. It is reducing a lot. It's not going to give you like any really good performance. I'm not using a lot of data, just a toy example. And then I apply my classification on top of that. I get my score. Now, what should I do if I want to get this score for my test? I need to apply the same thing that I did from Spacey to get my feature matrix. And then I get the score of my classifier. It's terrible. Obviously, I'm using like very little data. Now imagine I wanted to deploy this model. That would mean that this bit of code would be what you need in your backend to process your input, feed it to your model, and then get the output. That means that your backend is not completely agnostic with regard to what you're including in your whole machine learning pipeline. The idea is that the backend shouldn't know anything. The backend should unpickle, load some persistent model, call predict on the raw data, and then you have the output, and that's all. For that to happen, we would need to write a custom transformer. For that, let's talk about some of the basic API pieces we have in our estimators. We always have fit that takes X and Y and some extra parameters like sample weights sometimes. You have predict if it's a predictor. If you can predict the probability, you have predict proba. If your prediction is based on a decision function, for example, if you're doing a linear classification and your decision function can be something, the distance from the hyperplane that you have, then you can also have those. And they are used for like some interpretability or some calibration later. Transform for transformers, obviously. For example, if you have a PCA with 10 components, you get your n-dimensional data and it will output a 10-dimensional data for you. And then you have your score that takes X and Y, and if you have samples. But that also only applies to regression and classification.
Adrin, I have a question.
Yep.
So we have done transformation in the pipeline before. Why should I do it again in the backend to do other transformation? Why do I have this function?
So the thing is, the transformation was in order to get the embedding values of the input I have. In production, when you have your input, you don't have the embedding values. Your input is a sentence. Whereas your model, my SGD classifier, accepts that 300-dimensional data. It doesn't understand language. So you need to do that part of the transformation in your production to feed it to your final model.
Okay, thank you.
Right. So the this is This is really important because I see a lot of people when they develop their custom estimators, it's as if they've seen a similar talk like this one and they've stopped here. There's a little bit more to it. We use when you develop your custom estimator, we use something called composition instead of like complete like object-oriented hierarchies, as in there are different pieces that you put together to build your estimator. You can do that if your language supports multiple inheritance easily. And for a transformer, I need a base estimator. Any estimator needs to inherit from base estimator. And you need your transformer mix in. And there are certain things that are defined in those that you don't have to bother with now. But when you work in it, you only implement the parts that is important. You have your constructor. If you have any parameters here, for example, here I could take the model, the language model that I want to use as a parameter, and then I could test different language models. You store that in it, and you store nothing else. In fit, you store everything that you're going to use in your transform or your predict. And we have some conventions here. Anything that you pass to the constructor shouldn't have any leading or trailing underscores. So if I call my parameter here, let's say language model, and I give it a default, like, let's say if that's my default. Here I would say I don't have any leading or trailing underscores. Also, here when I call fit, basically pretty much any estimator you need to call fit before you call transform or predict on it, even if you're not really doing fitting on any data like this case. I'm not really, like here, I don't really care about the data. The only thing I do is I prepare my transformer. I prepare my estimator to work. So here I load my model and I store it in NLP underscore, and that trailing underscore, the convention says that this is something that is set in fit. And I know that the model is fit because it has at least one attribute which ends with a trailing underscore. And I also don't set it as none in my constructor. Your tests, your scikit-learn common test, which I talk about later, will fail if you do that. Certain linters, like if you use pylint, I think it will complain about that. It's a Python feature. We use it. Linters don't like it. So you need to disable those warnings. And then I have my transform. What I do is I call check is fitted self. It's a utility function we have. It checks if the estimator is fitted and it raises the right, it assesses the right exception if it's not. And then I just do what I was doing up there. I get my feature matrix. Something you see here, the reason I've done this is that Spatie uses some shared memory stuff that when you pickle your data, pickle your model, when you persist your model, that shared memory object is not included in the pickle. So if you unpickle that and you assume that your model is attached to your estimator, it's just not there. You will get an exception. Therefore, here, I try to do what I need to do with my Spatie object. If it raises this error, I just load it again. This is only needed if I pickle my model, I unpickle it. The first time I call transform, this is gonna happen. The second time, all good. And then I return my feature matrix. Another thing that here I'm doing is that I'm telling my test suite or other objects, estimators, meta estimators who use me, who are gonna like use Spatie transformer object, that my data, the types that I accept are only strings. Because by default, all the test suite will assume that you accept numerical data, and it will fail if you fail on that. So to recap, one of the utility functions that I used was check is fitted, which just pretty much checks if you have anything with it trailing underscore. Other stuff that you can use if you're dealing with numerical data are check array and check xy. What it does is that when I get the input, usually my input is either pandas or numpy. In my numerical models, I pretty much always need a numpy array. This check array will convert whatever I have into what I need. I can tell it, okay, I don't, it has to be two-dimensional or not. It has to be all finite or not. Do I accept sparse data or not? If I do, what formats of sparse, like SciPy sparse do I accept? And you can do that same thing with both X and Y, which has some extra checks on your data to make sure that the length of the X is the same as Y. These are all pretty useful because you don't want, you don't want to have random exceptions raised and doing validations yourself. These are all the validations that exist and you can just use them. So how do I test it? How do I test if this is something that I can use in a scikit-learn pipeline? We have, from the utils, we have the estimator checks, from which you can include parameterize with checks, which is a fixture for PyTest. And what you do is that you just write that and you say, I want an instance of spacey transformer to be tested in this function, and you just call check on your estimator. And then the way you test it is that you just call test. Like here, like this is kind of a trick to run the test in a notebook, and then it basically calls the test for you. If you're dealing with numerical data and you're not accepting what you say you do, it will raise. If you don't raise the right exception when something should be raised, it will tell you. If you're not implementing a method that you should be implementing, it will tell you. It basically checks for the API and a lot of sanity checks on your estimator. And then you can use it like as any other estimator that you have. You can create an instance, call fit on it. I'm not passing anything to fit because like my fit doesn't need my data. And then I call X and I get my, I call my transform and then I get the data out, easy. I can put that in a pipeline now. I can create a pipeline. The first step of the pipeline is my spacey transformer. The second step is an SGD classifier. And I can fit my pipeline with my train data and call score. How would I get, and call score on the test. So I fit it on the train, I call score and test, it's all working. And then I can even put it in a grid search. The same, it's just like I can check for my hyperparameters and try to find the best one. Here, all my scores are really low because I don't have enough data, but you can see that when I do the grid search, I get at least a little bit better result. It's not really substantial, but it works. And once you do that, your grid search object will also have your best estimator, which is the estimator with a set of best hyperparameters. And you can see what parameters from your hyperparameter set is selected. Any questions?
I have a question, Adrin. So the model used in my custom estimator is based on other estimators exist in Scikit-learn, right?
But now, can you repeat? Could you repeat, please? Is it my connection?
No, I think Hassan connection.
The model used in my custom estimator is based on exist. Should I repeat the question?
Oh yeah. Okay. It doesn't have to be. It can be. In this case, the custom estimator that I have is not based on an existing estimator at all because it's using Spacey. Spacey is not inside Scikit-learn. It's a completely different library. So what you can imagine here is, let's say I do PyTorch, and I train an embedding model in PyTorch, and I want that embedding model to be a part of my pipeline. Now I want to have something which looks like a Scikit-learn estimator, but under the hood, it does PyTorch stuff. Now you can wrap it around with a custom estimator and then use it here. And for that purpose, there is a whole library out there which is called Scorch, S-K-Orch. And it's basically wrapping PyTorch with Scikit-learn compatible estimators.
Mm-hmm. Interesting. Thank you.
So that's how we write it. Let's talk about some of the conventions that we have to review them. Usually, we pass a lot of parameters to the estimators, and we need to make the decision which ones are passed to fit, which ones are passed to the constructor. Think of it as fit should only accept data which is sample aligned. If you want to pass information about your features, you probably want to pass it to your constructor. If you want to pass something which is basically a hyperparameter, you definitely want to pass it to your constructor. We are working on handling non-sample aligned data very nicely in as a fit parameter, but it's just not there yet. Init should not set anything other than the parameters passed to it. If you don't do that, then your common test is one of the tests will fail. That's the only thing that init does. It doesn't do any validation. That's also very important. The reason it shouldn't do any validation is that the user can set parameters using setParam. As in, if, let's say, I have my grid search is an object, and it has n jobs is one of the parameters that I passed to my grid search. I can say dot set params n jobs. Now I want it to be 4, and then after that I can call fit. This piece of code is not going to run the constructor for me. Therefore, if I do the validation in the constructor, I would have to repeat that validation also in setParams. But setParams, I didn't even implement that in my transformer because it's implemented in my base estimator. So just don't do any validation in the constructor and do it all in fit, because we assume fit is always called right before you call the transform or predict. For example, if you're you have a penalty, and if your penalty is L1, another parameter is completely useless, and you want to say, hey, you're saying that my penalty is L1, but you're passing this other parameter, you shouldn't. That is the bit that you put in fit. It seems a bit counterintuitive because you usually validate parameters as soon as you get them, therefore it should be in constructor, but because of this bit, it needs to be in fit. The convention that we have for attributes that you attach to your objects. Attribute without leading or trailing underscore are the constructor parameters. With a trailing underscore are things that you set in your fit, and with a leading underscore means that they're private. It's not really private. Everybody can access all of them. It means that if you see something attached to an object, and it has a leading underscore, it means that I can change it without backward, I can break it. It's not backward compatible. It's not documented. Use at your own risk. But if I expose something with a trailing underscore, it means that it's a part of my API. I will probably tell you in advance if I'm going to change it. Another thing that I also used up there is that we have a bunch of estimator tags through which you can tell other objects that are going to use your estimator and tell them about you. Do you allow nans? Is it completely stateless? Do you support my multi-label? Is it deterministic or not? and there are like tests for these, and when these are the defaults, and if you change them, then those tests are not for you, are not run for you. And again, the way you add to your tags is that you implement this method, more tags, and you return a dictionary with the new values that you want to have. In terms of when you get into developing your own estimator, you start caring a lot about the APIs we have, and we are doing certain things in the API that it may be interesting to you, and you may want to look for. End features in. I think this one is actually already in now. Your model now, you can see how many features you have accepted. Just like, because before you couldn't. You didn't know how, if you have a pipeline, your pipeline, if you have a column transformer and you're doing a bunch of fancy stuff, and at the end of the day, you don't even know how many features are going to your predictor, to your like classifier, this is there to help you out. We may add end features out as well, which is useful for transformers. We're adding feature names, either through two attributes, feature names in and feature names out, or actually supporting pandas or xarray. And if you pass pandas or xarray with a bunch of feature names, we understand those, and the output will also be one of those objects with feature names attached to it. Therefore, you can actually look at your pipeline and see what's happening. Right now, if you have a pipeline and you want to, let's say I have a linear model at the end of my pipeline and I want to interpret the model, I want to look at the coefficients, but those are the coefficients to a bunch of features that I don't know what they are, because the features are lost. I have a few steps before that model in my pipeline. This is to fix that. And then we are also working on sample feature or generally data properties through passing them through fit. And it's going to probably introduce request props through which you tell your pipeline or your grid search that these are the objects, these are the attributes I need. For example, if you understand sample weight, you can do that. If you are working on fairness models and you accept privileged, unprivileged features or sensitive features, then you can say, I need these features. And then I would really recommend reading this page. This is our effort to document how to write a custom estimator. It is like everything a work in progress. And the things that you usually need are in one of these three files. Base.py, well, I guess I can show you where they are. If you go on GitHub Scikit-learn, you have the Scikit-learn folder, and there you have the base.py. Here you have all those classes that I inherited from. For example, the base estimator. You can see what it implements, what it does, and you can also see what else is out there. Another thing that is really useful is, what's that? Is the meta-estimators.py. One thing that I didn't, so the meta-estimators accept another estimator and they do something with them. And we also have conventions for meta-estimators. If you notice here, I have a pipeline and I'm passing the penalty to my SGD classifier to that pipeline. And then there's a dunder, underscore in between these two. That is the kind of API or convention that we have. And the classes in meta-estimators do implement that for you. So you don't have to understand these. It makes it much easier to write a meta-estimator. And then you have at the end, the validation, which includes a lot of validation methods. Anything pretty much, I think pretty much anything that doesn't start with an underscore is public and you can use it freely. If it starts with an underscore, it's probably still useful. That's why it's there, but we may change it. And that's all. Thank you.
Thank you very much, Adrin. Now it's the time for your questions. If you have any questions, please feel free to leave it in the Q&A box below. I have a question, Adrin. Can I go back to the GPU point?
Yeah, sure.
My question is, when Scikit-learn gonna support GPU?
Haha. Let me see. I think, do you know, well, no. So one thing we have in the PyData ecosystem right now is, or rather we always did, NumPy. NumPy does, you can think of NumPy as like these two different things. One of them is that it does a lot of numerics for you, or like not, it doesn't necessarily do them because like SciPy does most of them. But NumPy stores the data for you in a very specific API. It exposes that API. The other thing that it's doing is that it's giving you the API. It's defining that API that everybody else could also use. And in the old days, you had ufuncs through which would mean that you write your own object, but you want users to work with it as if they were working with a NumPy object. Or you want that object to work together with a NumPy object. So you want to store your data in your own way, but you want it to work if the users say, this ND array plus your object, NumPy should know which method to call or how to do that plus, how to apply that function. And then that had its own caveats, and the more recent API is the array function, dunder array function. And a lot of libraries are implementing that now. I think, if I'm not mistaken, you have CuPy, which is like CUDA NumPy. It basically gives you the same NumPy interface. If I'm not mistaken, I'm almost certain that it does it through array function. Xarray, I think, does that. Dask array does that too, I think. Which means that I can work with all of them. Now, that also means that if the only thing I do to my data that I get are those NumPy functions, or I just use the standard things, it would mean that I don't have to care if it's actually NumPy or not. As long as it implements that API, I call what I need to call on it, which would also mean that if it's a CuPy data and it's on GPU, it lives on the GPU, and I call those functions on it, it's gonna be on GPU. And then you do have, these are like, these two pull requests are what we are doing right now on supporting that for PCA. We are experimenting to see like what it looks like for us to support that. As in that the user would give us something that supports array function, and we understand that. Because right now, if you call check array, that utility function, it definitely returns a NumPy array for you. Almost definitely. So you're losing all the capabilities that you had and all the fancy stuff. And I think we have some really nice benchmarks at the end of this PR. Is it here? Or it was the other one? No, I don't see the benchmarks, but it works. For one or two of the transformers, we're experimenting with them, and obviously it's in the milestone for us to support that as much as we can. The limitation is a lot of our algorithms are not written in Python. Pretty much anything that needs to be fast is written in Python, which is compiled into C. It's basically C, which means that I need to access my data in memory. I need to know where my data lies. And if I get a data which is on GPU, that same code is not going to work for it. So there are certain restrictions for those, but for certain transformers that they don't really need that, we can start supporting
them. Okay, thank you. Thank you so much, Adrin, for this detailed answer.
Sure.
I have another question about Suppose if I have created an amazing custom estimator, and I want to contribute it to the Scikit-learn project. What are the procedures that should I take to publish it to this library?
There are a few different ways that you can distribute your like contributions or your transformers or your classifiers or whatever. The inclusion criteria for the main package is pretty hard. We pretty much look at the publication that introduces that model. And if the publication is very well established, and usually we're like, if it has at least 200, 300 citations, then we can think about including it. But what we do have is the Scikit-learn contrib.org, which includes a ton of libraries. These are contributed by third parties. And the inclusion criteria for this is much, much lower. Basically, your models need to be Scikit-learn compatible. You need to have a working CI. You need to have it documented, and you need to have a minimum test coverage. Then you send a request and you're like, I want to include this project here. We move it here and we give you ownership access to that same repo. It lives here. It gives it a little bit of visibility. And you do see things like we have some that do, like the HDB scan is a really nice clustering algorithm. We haven't gotten around of including it in the main library. It's there. We have some time series related stuff. We have imbalanced learn that like deals with imbalanced data. We don't have a lot of very imbalanced data specific tools in Scikit-learn necessarily. Like this does a lot of that for you. Yeah, and then on top of that, we have Scikit-learn Extra. So if you have something which we're not sure about including in Scikit-learn, but it looks pretty good, then it can be included here. We maintain the CI here and we distribute it. So the users can install Scikit-learn and Scikit-learn Extra, and then they have everything that is also included here. Yeah, I guess that should answer that.
Okay, yeah, thank you so much, Adrin.
Is there any other question? Hassan?
I think that's it. We covered almost all the questions.
Sure.
There is one in the Q&A.
Yeah, there's a new one. The question is how our custom Scikit-learn estimator carries to making predictions. So again,
I need clarification on that question.
could you elaborate on this? I think means how to predict using my custom method. I think there is we discussed already the function that makes prediction. So I don't know.
Basically, maybe this would help. If in here I had a transformer, if instead of a transformer I wanted a classifier, I would have classifier mix in here. And then instead of a transform, I would have to implement the predict method. Therefore, now my custom estimator is a classifier and it exposes the predict function. Therefore, you can get a prediction out of it the same way that you would get from a Scikit-learn predictor, if that's the question. I'm still not sure.
I hope this answered the question. Thank you, Adrin. I have another question. So today we have learned that Scikit-learn library offers a great tool for deploying my work. So what about the customer? How will the customer be familiar with this library? How to communicate with the customer using this library? I'm afraid that my customer is not familiar with Scikit-learn library. So what do you say about that?
Well, in like when I was a consultant, a part of it is to teach them what they have as options. So a lot of my job, like for 2 years at least, 2.5 years, I was a machine learning consultant, and a lot of it was that I would tell them how they could optimize their code. It's like to the like, and it's not just scikit-learn. I optimized a pandas bit of code, which was run. It used to take a few hours to run. With a few changes, it would take a few seconds. And I didn't do anything fancy or anything low level. I was just running, I would call the right methods from the pandas. You just need to know a little bit about the internals, like to know what you need to do. And it's the same with Scikit-learn. It's just you need to understand that a part of your job, if you have customers, is to educate them and teach them that these are the things that they could use. One of the things that I was doing was that instead of writing them code, I would audit their code. So they would give me access to the repo. I would go on the repo and I would start filing issues and be like, well, these are the things that you could improve. So a lot of it is just really education. In terms of deployment, so these things really help with deployment, but there are limitations to deployment in Python or using these tools, which you have to deal with, but not always. If you, for example, if you use very standard scikit-learn methods, you don't have anything custom, you can use Onyx to deploy your models. I'm not sure if people are familiar with that. Onyx is you could call it a language, I guess, and a runtime developed by Microsoft, which, so before Onyx, we had PMML as an example. With PMML, which was this thing that you basically persist your model in kind of an XML format. And then you have an engine, which was the default was a Java engine, that would load that persisted model and serve it. As in, let's say I have a linear model, I would persist my coefficients into that XML, and then my runtime would load that and it would know that this is a linear model and the output is the linear combination of these features with these coefficients. So it would know like how to run the model. It didn't know how to train the model, but it would know how to run it. It had a lot of issues. And after that, like you could think of it, Onyx as kind of a next generation from that. If I'm not mistaken, this is Turing complete, which means you can include all the logic of your model there. And the runtime is in C++. So what you can do is that you persist your model and then you serve it with Onyx. And it also supports GPU, it supports TensorFlow and PyTorch, if I'm not mistaken. It definitely supports some neural network format. Like you can export your model, whatever framework you use, into the format that Onyx understands, and you can serve it there. And these are way more reliable in terms of serving. The issue with them is that you don't necessarily have all the conversions that you need for all the libraries that you have out there. So the like there is some stuff out there. They're working on it. It works for a lot of scikit-learn, just the standard ones, not necessarily all of it. And it also handles the issues that you have with pickling. Pickling is not supposed to be, so basically you're not supposed to pickle in one scikit-learn version and then unpickle and use it in a different scikit-learn version. I'm not sure if it's supposed to work between Python versions that easily, and it definitely doesn't work between architectures. So for example, your architecture, I think if you are in Intel architecture, or like x86, it's Lillendian, I think, as in like the order of bits of a number. What is it? Is it the highest value comes first or the lowest value comes first? That's just an arbitrary thing that we decide on. And some architectures decide the opposite from the other architectures. And when you pickle something, you're dumping that binary data. If you pickle it in one architecture and load it in a different architecture, that would mean that you're basically getting corrupt data. Which the consequence of that is that I have a server. It's usually, let's say it's an AMD or Intel CPU. I train my model, I save my model, but I want to serve it on mobile phones. It's ARM. And you do have these differences between them because of these architectural differences. You can't necessarily serve the same model that you trained on that architecture because of the pickling issues. If you want to fix those, you can use something like Onyx.
Okay, thank you, Adrin, for this detail.
Sure.
Great. Is there any other question, Hassan?
I think that's it. We covered all the questions we have.
Cool.
Okay, I think that's it for our webinar. Thank you, Adrian, for your time and your awesome talk.
Thank you.
For our audience, thank you for joining, and stay safe and stay tuned to know our upcoming meetup. And yeah, see you next time. So yeah, I think that's it.
Thank you.
Bye bye.